So, oh yeah, 1 over
What number is
x equals 1.
Oh,
You want Taylor. So I think the way to do this is to go through the pattern, try to figure out the pattern. So you know that it's going to turn out to be a series from n equals 0 to infinity of an nth derivative of 1 in this case over n factorial times x minus 1 to the n, and then all you need to do is to give me a pattern for this. All right, and figure out where the pattern starts. So write your columns. Okay, and then good tip is when you see this, when you see like a Taylor question that's going to be a pattern question, write this formula down. You'll get some points for just writing this down. Nth derivative of a, so some nth derivative of a over n factorial x minus a to the n equals 0 to infinity. I'll already give you some credit just for writing that down, even if you can't figure out the pattern at all. So write it down, let me know, guide me, tell me where you're going with this, and then make your columns. So 3 columns. So 1 column, 2 column, 3 column. So this column, your first column, is going to be for tell me what n is. Your second column is going to be for your nth derivative of x, and then your third column will be your nth derivative of a. And so for the general nth term, we want to find out what's in this box down here. So we want the third column nth row. And that's basically all you got to do. But to get there, you got to write it. Write some terms down, try to figure out what it is. Okay. So when n is 0, it's just the regular function, which is 1 over x. So it's 1 over x. This is 1 over 1, so it's 1. So 1 goes in that first row in column 3. Then when it's 1, we have to take the derivative. So the derivative, I would see it as x to the minus 1, so it's minus 1 x to the minus 2. So it's minus 1 x to the minus 2. And then this is easy because when you plug in 1, you're just going to get 1 here. So this is minus 1. So we got 1 minus 1. Okay? Now it's the next derivative. 2, it's the second derivative. It's going to be positive 2 x to the minus 3. Well, every time you plug in, you just get a 1 there. So that's good. It just becomes 2. So this is not a hard pattern. So now 3, what's happening? Negative 3 factorial x to the minus 4 or minus 3 factorial. Let's do one more. 4, it's going to be positive 4 factorial x to the minus 5 or 4 factorial. So if you kind of see, when it's 4, it's a 4 factorial. When it's 3, it's a 3 factorial. So when it's an n, it's a n factorial. So that's going to be there. Now, what about the minus sign? When it's a 3, it's negative. And then the next one, 5, is going to be negative. So looking like odds, it's going to be negative, and evens, it's going to be positive. So that's a negative 1 to the n. So that looks pretty easy. And then where did it start? Where did the pattern start?
what is it?
1.
Negative 1 to the n.
So is it okay? Is it, because 0 factorial is 1 and 1 factorial is 1, and then, yeah, it looks like the patterns throughout. Patterns throughout. So you can just say the pattern is starting throughout. All you got to do is take this and throw it in the box. and the n factorials cancel, so we're just getting series minus 1 to the n, x minus 1 to the n.
Could you show the canceling out?
Hmm?
Could you show they cancel out?
Well,
Is it just the
n factorial divided by n factorial.
Yeah,
is
yeah,
just-
just, never mind, sorry.
Okay? So pretty easy pattern, not that bad, yeah? Not that bad at all. Come on. Okay,
Maclaurin series?
Maclaurin series for e to the minus 7x. Okay, you got two options here.
The easier one.
I guess I'm always staying on this board, right? So I gotta erase this board so everyone can see. I'm missing the big faculty meeting
Senate.
of all the faculty down in Aloha Tower where they get together and
Why
they
they really
talk about all the stuff they've done in the faculty senate, which isn't much, but they'll make it sound good.
It's on video. Don't worry.
Oh, okay, take that back.
They can.
Take it back. Take it
Great accomplishments, and then
Yeah.
Okay.
you did a lot. You did a lot. You did a lot. Absolutely, yeah.
Get it.
So, a lot of clapping, well-deserved clapping and applauding. Everybody, clapping for everybody, and it's all well-deserved. Okay. So, this one you got two options. So you got a e to the minus 7x, and you've got two ways to go with this. One is just methodology. In other words, you have e to the x is equal to a sum from n equals 0 to infinity of x to the n over n factorial. Right? You have that, and so methodology, you're just going to substitute this term for the variable within the rule. So in other words, e to the minus 7x is a sum from n equals 0 to infinity of minus 7x to the n over n factorial, which is a sum from n equals 0 to infinity of negative 1 to the n, 7 to the n, x to the n over n factorial. That would be, I think that's the easiest, right? Just methodology. If you get an easy one like that, it fits into something you already know about. Now the other way to do it would be the pattern way, so that you would say, you would make your columns again, and you would say, well, we know this is going to be a sum from n equals 0 to infinity of an nth derivative of 0 plus Maclaurin over n factorial x to the n, where this is f of x. And then you're going to go through your pattern. So you're going to have your column, your nth derivative column, and your nth derivative of 0. So here you just have e to the minus 7x. When you plug in 0, e to the 0 is 1. Okay. Now when you take your first derivative, what happens? The chain rule, that minus 7 comes out. Now every time you plug in 0 here, you get 1. So here you get minus 7. And when you go to 2, then another minus 7 comes out with the chain rule, so you get a 7 squared, and you get an e to the minus 7x. Every time you plug in 0 here, you just get a 1 for this. So here you just get 7 squared. So you can see what's going to happen. The next one is going to be minus 7 cubed, etc. So when you go to the box, you can see that when it's an n, you're going to have a 7 to the n. And when it's a 3, it's negative. When it's 1, it's negative. When it's 2, it's positive. So you've got a minus 1 to the n. So you just figure that pattern out. So inside that box, to make it bigger, is minus 1 to the n, 7 to the n. So you're just throwing that up here, and you end up with what we already know from the methodology. So that would be the way to go. Yeah, either way would be fine. Yeah. So you figure out the pattern. I guess this is too small for the tape, but so I enlarged it here. So I'm running out of room there. Okay, so there you go. Questions? Yeah, pretty straightforward. I'm not giving you a real difficult one, right? It's not really on these things. Okay, so what else? Oh, convergence question. So this is, yeah, this is an easy one.
You have to put that into the equation, and then you got that.
So number 3 on 2012, so. Okay, so if you get something like this, you just filter out all the kind of unimportant information. So that 797 is just there to scare you. That, you know, who cares about 797 n to the 8th, right? Just look at the leading power. It's n to the 19, and it's n to the 21 down in the denominator. So all this stuff here is really irrelevant if you think about it. So really, this kind of looks like, doesn't this kind of look like a 1 over n squared? Right? So that's limit comparison test. So do your, say, your series 1 over n squared converges. So that's going to be your series, that's your known, your series Bn. Run your limit comparison test, take a limit as n goes to infinity of 7n to the 19 plus all this stuff. And 8n to the 21. When you divide by the 1 over n squared, it's going to flip, so it's going to be an n squared over 1. And then this is going to become a 21, this will become a 10, and this will become a 4. But then you know that it's 7/8 from Calc 1. Because you just factor out the n to the 21, right? So you get an n to the 21 and an n to the 21, and here you have the 7 plus. This is the 797 over n to the 11th, and you're subtracting the 104, and what is this going to be? N to the 17. And then the same thing down here. You cancel these. Here you've got just the 8. And these go to 0 when n gets big, so you take the limit. N gets big. These go to 0. And you're left with 7 over 8. 7 over 8 is a positive constant. You're in the case 1 of the limit comparison test, the full information. So whatever this series does, this series will do. And since this series converges, right, this is your p-test, integral test series, your 1 over n squared converges. So converge. And then just write converge by the limit comparison test so that you explain that I know you're using the test and I know you know that this is a case 1. You could even say converge by the limit comparison test, case 1, full information.
Because 7x is greater than 0.
Yeah. So remember, if you get a positive constant, whatever your known series, however it behaves, your unknown series will behave the same way. If you get 0, you only get information if your known one was convergent, and you get infinity, you only get information if your known one was divergent. So you get partial information. Here you get full information. So converge. Yeah? And so, yeah, this is like, I don't know, I've done these. You might get one like this where I just change the numbers, make some weird number there, put this, n to the leading power might be n to the 58. Here it might be n to the 61. So you would do a comparison test with 1 over n cubed, easy, right? But for some reason, even though we practiced this, like in those previous years, a lot of people still didn't even get it, and they did some strange stuff. So don't be like that. Be the class that gets it, right?
So,
Clear?
So what should an NQ that's converging?
Yeah.
So let's look at the
1 over n to the p converges when p is greater than 1.
So if you said 21 to 22,
Okay? Series 1 over n to the p. So, you see factorials, you're probably thinking, what test? Ratio test. So you see a bunch of factorials, you probably think ratio test. Okay. So let's do the ratio test. So we're going to take a limit as n goes to infinity. Remember, it's a limit as n goes to infinity of a sub n plus 1 over a sub n. And the test is going to be greater than 1, less than 1, equal to 1. 1 is the kind of the point where you're going to be comparing these things to, this limit to. So let's see what the limit actually is. So the limit as n goes to infinity, that's going to be n plus 3 factorial, an n plus 1 factorial, a 2 to the n. Then when we're going to divide by this, so we're going to multiply by the reciprocal of this. So n factorial, 2 to the n minus 1, n plus 2 factorial. And now we've got cancellations. Okay, so what's the cancellation here? What's the cancellation?
n plus 2 factorial with the other factorial.
Yeah, so just have n plus 3 left. So all of this goes, and then that goes. Okay, so you just have n plus 3, and then same thing here, all of this goes, but just the n plus 1 remains. And then all of this goes, and then just the 2. Okay, now what is the limit of n plus 3 over n plus 1? 1. Yeah, it's clearly 1. So this whole thing goes to a half. So this is a half. Half is less than 1, so
oh, it's because it would be,
what are we doing?
Oh, there's a 2 here.
Oh, this is
Remember this 2?
diverge.
It didn't go away.
What?
times 2.
Wait, converge.
Converge.
Sorry about that.
converge.
So this is more.
Less than 1,
Okay.
converge by the ratio test. So you say converge by the ratio test. Okay? Easy one, not so bad. See, it's all like, it's not so bad. None of this stuff is so bad.
Hold on, Jeff, hold on, let me get a picture.
Okay.
Thank you.
Well, it's all gonna be up on.
Yeah, I know.
I took that one away.
Wait, why was it 1/2?
Because that 2, there was a 2 in the denominator.
These like cancel, right? That's why, because they're both going to infinity.
We
So
had
it's
a,
like
we had a
infinity.
2 to the n minus 1 over a 2 to the n, so everything canceled except the 2 in the denominator.
Yeah, like these
And
cancel.
the
so
other
it's just
piece
two.
went to 1.
Oh,
Yeah?
okay.
We had like an n plus 3 and an n plus 1 or something.
Those
Oh,
go
yeah.
to 1.
Then we have this,
That's why.
we had this, and this
So it doesn't really
piece,
matter.
this piece went to 1 when we took the limit, but the 2 is still
But
in the
are you
denominator,
plugging
so
infinity into that?
so a half.
How does that equal, how does that go to 1?
Oh, use the
if you're
L'Hopital's
plugging
rule.
Oh, okay.
Okay, so looks like we've got, here is one, let's see, I'm looking at, which exam am I looking at? Oh, I was doing this one. Okay, yeah, okay, so here's an evaluate. All right, so when you see an evaluate, you know that evaluate a series, it's gonna either be a geometric series or it's gonna be a telescope. And I've actually given you one of each because I have a part A and a part B. So I've got a sum from n equals 0 to infinity of 8 to the n plus 1 over 9 to the n, very easy problem. And I've got a sum from n equals 2 to infinity of 3 over n minus 3 over n plus 1, also very easy problem. So what do you do in the first one? With what? What's your R?
8 over 9.
And what's your A? What's your A?
No. 1.
Anybody? What's your A? Your A is what? That's quite an A.
Hang on. Make this up.
No, it's, look, it's, you have to get it in form A, R to the N. So what do you do with this n plus 1 as an exponent? What do you do with it?
8n plus
What do you think of an
8n, not plus 8, but times 8.
8. Yeah, 8n times.
So you make this n equals 0 to infinity, 8 times 8 to the n, divided by 9, 10. We're just doing a little algebra, and then you do another little rule that you learn, I don't know, in one of those classes like Math 1101 or whatever those things are. You make it that, and that's your R, that's your A. You're starting at 0, so you can just go straight into the formula, A over 1 minus R. So this is 8 over 1 minus 8 ninths, or 8 over a ninth, or 72. Easy one, yeah? Easy one. Okay, what do we do with this? We just kind of plug in and figure out what the general SK looks like. In other words, SK is a sum from n equal 2 to k of 3 over n minus 3 over n plus 1. So we just want to plug in, figure it out. So it's 3 halves minus 3 over 3. Then it's now it becomes a 3, so it's plus 3 over 3 minus 3 over 4. Now it becomes a 4, so it's plus 3 over 4 minus 3 over 5. Everyone see what's happening? Okay, and then it's etc. Now it becomes a 5, so it's plus 3 over 5 minus 3 over 6, and it keeps going dot 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 dot. And then we finally get to 3 over k minus 1 minus 3 over k, and then the last one we get is plus 3 over k minus 3 over k plus 1. And so we get cancellation, and then this guy will cancel with the previous one, and this guy will cancel with the previous one, and these guys will cancel, and these guys will cancel, and these will cancel. And so we keep everything in the middle. This is going to get sucked out with the next one over there. And so everything gets sucked out except the first and the last. So this is going to be 3 over 2 minus 3 over k plus 1. So that's going to be your SK. So then the series is a limit. Limit as k goes to infinity of SK, which is a limit as k goes to infinity of 3 halves minus 3 over k plus 1, which is 3 halves. Okay? So telescoping one, it's the easy one.
So what is k minus 1 and k plus 1?
Hmm?
What do you mean by that?
Well, I'm just saying that
The constant.
n is gonna go 2, 3, 4, 5, you're gonna bump up. It's gonna get to k minus 1, you keep plugging in, and then its last thing is gonna get to k. So just, when it was k minus 1, you're gonna get a k here. That's gonna cancel what happens when you actually get to k, it's gonna cancel with this. So I'm just kind of letting you see that.
So,
Basically, everything in the middle gets sucked out.
And the answer would be the limit, I guess.
Yes, then you take the limit. Remember, because a series by definition is a limit of the k partial sum as k goes to infinity. That's the definition. So when you have, whenever you see like n equals 0 to infinity, right, of a sub n, by definition, we mean the limit as k goes to infinity of the sum of n equals 0 to k, right?
Oh, this is R and this thing.
This is just the definition, right? It's the, you're taking the k partial sum and then taking the limit. Because remember what the series is, it's you're going, this sequence, A0, A1, A2, etc. And then you're doing the S sequence. So
okay,
you're doing A0, A0 plus A1, A0 plus A1 plus A2, etc. And the limit of this sequence, we're calling the series. This is the thing that we need to go to 0 in order for the series to have a chance. Right? So you always think there's two sequences involved when you see a series. There's the A sequence and the S sequence. We're interested in whether the S sequence is converging or not.
So it's 2, 3.
So can we skip the whole canceling off part?
Well, you gotta show it. I
And
think
just
you
put a
just,
middle of it, you don't have to put that.
yeah, I think you just kind of show it.
Okay.
Why does the 3 over k minus 1 cancel?
What is what?
The 3 over k minus 1. How does
Well,
that
it's gonna
figure out?
cancel with the one before it, so when we got to k minus 2, we're gonna be subtracting k minus 2 plus 1, which is k minus 1, so the one before it is gonna be a minus 3 over k minus 1, it's gonna cancel that.
Shane, do you wanna take
They're all
pictures
gonna
of this, cause
cancel.
this is from.
Just have to
entire
see the
beginning
pattern,
process.
Okay?
Yeah.
Yeah. It's easier for sound to go through. The next one's the alternating series. Not after What? For this exam. I don't want to depend on the curve, but.
Okay, so where are we? Okay, yeah, all right, look. You see that -1 to the end? I'm really trying to give you a nice hint, right? So probably I'm giving you alternating series. I mean, you're just starting out, and if I tried to trick you or I wanted you to do something else, it wouldn't be that nice. It's probably just take the hint, right? So,
I'm down. Take the hints.
Gotta start somewhere. You're doing just fine.
okay, so might look scary, but it's really easy because it's alternating, and then all you gotta check is 3 things. So you run an alternating series test. So all you have to know is, does this part, right? You think of this as alternating, and there's the Vn part. Is it positive?
Yeah.
Sure. So 1, okay, so 1 over, it's a square root of 5n plus ln n. Your terms are greater than or equal to 7. Those are all going to be positive. 2. If I put an n plus 1 here and an n plus 1 here, would I get something smaller than this thing?
Yeah.
Yeah, because easy. If I increase the denominator, then the whole thing is going to get smaller, right? So these you don't even have to make much of an argument. You can say, okay, this is clearly smaller than this. So already I've got 2 steps, and then what's my 3rd step? Yeah, I just take the limit as n goes to infinity of 1 over the square root 5n plus ln n. It's going to keep growing and growing as n gets big. 1 over the square root of big is getting really small, so just easy calc 1 argument goes to 0, you're done. It's that easy. It's a gift. It's a total gift, yeah.
If it fails the 3rd test, does it die?
That is a gift though.
Just by the divergence test? Or is
It
that
would,
minus 1 over n?
yeah, if you had,
Yeah, it is.
if you had this whole thing not going to zero, it would fail the divergence test. You could not.
Let's go right now, let's go.
That's good.
Let's take it right now.
So you just need the first two.
So if this,
So you just
well,
need
it
the first
depends, if
example.
you ran a divergence test first.
Other example exams.
But the third one is a
Use
divergence.
this, see if I
With
can
the exception of the negative
No,
one.
no. Different.
And then we're still.
The divergence test, if this doesn't go to zero, then you get information that it diverged.
Yeah.
But if it went to zero, you wouldn't get any information. But if you'd already done that, I mean, this is kind of a silly point, if you'd already done your divergence test first, and you already took care of this, then you could just do those. But you would still have to write this down as part of the alternating series test. Okay, but we're just talking about really nothing significant.
No, I'm just saying that
You know what I'm saying?
if you do this first, then you see that the third one fails.
Well, if you
Then you
do,
can say divergence.
if you do this first, if you did this first and you notice that you had a problem here, you might then say, oh, I could now do the divergence test. Okay.
Eventually do this first.
I told you.
Yeah, he could. He could have the final.
Did anybody do the extra credit, by the way, where, so the extra credit, by the way, was to give you one where condition 1 and condition 3 of the alternating series test was satisfied, but condition 2 failed and you got a divergence.
Yeah, I did it.
You did?
I'll give
You wanna
the
show it to
final.
me?
No, I'll let him final.
Are you just gonna hand it in on the phone?
Oh, do I have to show it to you?
Well, you want the extra credit, right?
I'll do it.
I mean, if it
office
does-
hours,
You just, I'm not gonna take it on faith without looking at it.
Office hours, I'll show you.
Okay, yeah, sometime you gotta show it to me.
Can I get like 20?
It's extra credit, right? I can't just do it by ESP or something.
20 points, right?
I don't know.
It's in the second, fails in divergence.